Hello and welcome to our webinar on Arango 3.5, the latest release of ArangoDB. So just some house rules here. Feel free to ask questions at any time. There was already one question in the chat. You're all muted, so please just put any question you might have in the chat here, and I'll either try to answer them during the webinar if I actually see them, or I'll come back to questions at the end. This webinar is going to be recorded, so also the recording is going to be shared later on if you just want to go back and review it, and also the slides are going to be online afterwards. All right, what is this webinar actually about? So we're going to talk about Arango 3.5. So here's kind of like the TLDR. So if after this slide you decide not to join any further because you got all the information, that's okay, but this is kind of the short summary of this webinar. So Arango 3.5 was released about 1.5 weeks ago, and then it actually includes a number of really cool new features. So probably most prominently, there are some improvements in terms of Arango Search. So if you're actually using the NLP and text search capabilities of ArangoDB, we got sorted views and configurable analyzers. And the other cool feature, which I particularly like, is the SmartJoin feature, because it actually enables you to really scale your cluster to more nodes and still keep kind of similar performance to what you would expect from a single node database. Otherwise, we have a number of improvements in terms of graph capabilities. So for example, k-shortest path queries. If you don't just care about the one shortest path, but actually a number of shortest path queries. And another pretty cool performance improvement is actually the PRUNE keyword, which enables the query to abort early if it can actually verify that there are no further results. So if you actually have queries across large graphs, this is going to accelerate your queries by quite a large factor. Other improvements include streaming transactions. So you actually now have driver support for the transaction feature, and also data masking and time to live features. So especially if you're dealing in GDPR controlled environments, this is pretty helpful because you can still ask analytical queries to your data without revealing any private personal information. The other feature, which actually didn't quite make it into the 3.50 release, but it's going to be out in about 1.5 to 2 weeks, it's the hot backup feature. So many of you might have used ArangoDB before to kind of store, like backup and restore their databases. And one challenge here is that actually if this is done across large clusters, and it's going to take a while because you have large data sets, it might actually become inconsistent. So with hot backups, we now have a new backup options which enables you to take consistent snapshots across your entire cluster. And the other cool feature is it's actually dealing with kind of the underlying storage structure. So it's not kind of as ArangoDB would do, just outputting all the SQL commands, how you can re-import your data, but it's actually just dumping away the underlying file structure. So it's also much faster compared to ArangoDB. All right, as mentioned, this is kind of the short summary. We'll dive into more details during this webinar. But if you would just want to know who am I actually here telling you about ArangoDB, I'm Jörg. I'm the head of engineering and machine learning at ArangoDB. I actually just joined about 4 months ago, but I've been working with ArangoDB as a partner and user for the past, probably 4 years, where I was working at different companies. So I've been kind of switching back and forth between the database space, where I did my PhD, where I worked at SAP on one of the architects for HANA, and large-scale distributed systems at Mesosphere, or building large-scale machine learning infrastructure at Suki AI. So, all right, let's dive in. For those of you who might actually not be aware of what ArangoDB is, I promise this is the only introduction slide here, but ArangoDB is actually a multi-model database. What does multi-model mean in this sense? So you might have heard about graph databases like Neo4j or document databases like Mongo. And typically, in my experience, those are really cool databases. But typically, the use cases I encountered so far in production use cases, they don't involve a single data model. They actually involve multiple. So for example, I might have a data model where I actually require some documents, but then also some graph structure in between them. So what I've seen in the past is people actually take multiple databases and then they write like a large application layer on top, potentially providing support for transactions and everything else in kind of the layer above, which needs to be maintained by your developers, which needs to be coded and hence is like a significant investment of time and resources. The idea of ArangoDB is to actually just keep all those different data models inside one database engine. This means, first of all, you have the performance across all of them. You don't have to ship data out of them if you want to, for example, have joins in between different data models. And also, for example, transactional guarantees are guaranteed across all of them. The other big advantage from a user perspective is simply I have a unified query language, so my developers only have to deal with one query language. And furthermore, also my DevOps team, who has to maintain those databases, only has to maintain one database. The other nice feature of ArangoDB is it's actually a large distributed database. So we can also handle graphs crossing more than a single node, which actually will become important if we dive into some of the features during this webinar here. The other big announcement, kind of like parallel to the 3.5 release, is actually the release of Oasis, which is our managed cloud service. Right now, it's in a private beta phase, but you can just apply to get an account. And this actually means that we're going to manage your entire cluster. We are going to provide scaling options, and we're basically making sure that it runs and you don't have to set up anything. So it includes the enterprise features, and it's basically usage-based pricing. So the more nodes you want to use, the more nodes you're going to be charged, but you're only going to be charged for whatever you will use here. And as for this webinar, we actually need some demo in the end. And so just to basically give us a chance to start up our demo instance, I have one already running, but we can just start up a second deployment. Let's briefly switch over to Oasis here. So we can see we have our webinar org for all my webinars. And then we have our projects here. And this is currently our demo project. Let's switch to deployments. This is my first demo deployment, which probably we're going to use later on during this webinar for queries. But for now, let's actually just create a second one. Let's be really creative and name it Demo 2. We can actually put that on Amazon for now. Of course, as it's a 3.5 webinar, we're going to use our 3.5 database version. And as I'm currently in Germany, we also want to place that here in Germany. This all looks fine. I only need a tiny instance, and let's just hit create here. And this hopefully triggers the create in the background. Yes, looks good. And we'll check back here in just a second. All right. Now, after having done that, let's actually dive into our 3.5 features here. So what is new in version 3.5? We already mentioned the SmartJoin feature before, and let's actually see why we need something like that. If you have a large distributed cluster with documents and different collections spanning different nodes, joins might become really expensive. So here we have two relations or two collections, M and B. And if we naively want to join them, we actually end up with a lot of traffic between different nodes. So for example, we have to transfer some data from database server 2 from collection B2 to M2 and so on and so on. So actually this ends up in a lot of network traffic, which typically involves a lot of latencies. Those of you who might be aware, this is actually a really cool comparison. Latency numbers every programmer, or actually also every DevOps person should know. We can see that the latency or round trip times even in the same data center are actually here in this range, whereas normally we're actually more here in this range where we're dealing with normal memory lookups. So we are like an order of magnitude faster. So we have a pretty strong interest in actually keeping everything within the same node, because then we don't incur this cost over here. How can we actually do that? With the smart join feature, we can actually co-locate certain charts. So as we can see here, we have two collections. First of all, products, which might be a smaller chart describing like all of our products. And then we actually have our orders where people have ordered those different products. And so what we do, we actually shard the first collection here by its normal shard key, which is going to be the key for our product collection. And then furthermore, we actually say that we want to distribute our shards for the second collection orders in the same way, because we use the distributed shards like feature here, and we say they should actually be co-located the same way, and we want to use it should be distributed like products, and the sharding key for our orders collection, which matches this key up here, is actually product ID, which makes sense because this is the referential key pointing over to products. All right, after we have done so, we can now actually run the same query, and we're going to see that all of the joins are just happening locally in the node. So the charts for the product collection here, M1 and B1, they're on the same node. So we can basically join this here, and then only the final results have to be sent over the network to the coordinators. But we actually save all this network traffic we've been seeing before in between those nodes. So this typically ends up in a big improvement. I would personally say the downside is we actually have to know those sharding keys up front. It makes it a bit harder to run efficient ad hoc queries, but we can still run all these same ad hoc queries and optimize for our typical use case we expect here. All right, this is our smart join feature. The other features are especially in the Arango Search area. So Arango Search is the full-text search engine inside ArangoDB. And this actually allows you to create views from analyzers. So what is an analyzer? If you have previously worked with, for example, Elasticsearch or with any other search engine, you might be aware of that. This is actually the part which kind of tokenizes. If you have a large document, you want to split it up into individual words. You might want to drop certain stop words, for example, indexing the common term Z, or kind of like a nonsense words. Probably want to drop them from our view and only index the relevant features. And so this is basically what our analyzer is doing. It can do further things. So for example, if we want everything lowercase, if we want certain stemming options, we can do the same here. And this is actually one of the features that we now have configurable analyzers. So you can create case-sensitive search, case-insensitive searches, or actually use enhanced stemming based on your different use cases here. The second feature we added for Arango Search is actually the sorted inverted index, so sorted views. And this actually goes back to how we can utilize multi-sorting before. And in certain queries, because we know the relations and views are sorted up front, this can actually lead to pretty large performance improvements if we can utilize that. All right, the other cool features are actually in the graph area. And in the graph area, already mentioned on the first slide in the TLDR, we actually have k-shortest path query support now. And this is, for example, useful if you're on a map. Obviously, you want to go to another city. K-shortest path is quite intuitive. I want to know the n shortest ways to go from A to B. But it's also useful for many other use cases. So for example, in cybersecurity, where I want to figure out different attack vectors, where I want to figure out certain routing algorithms, this k-shortest path algorithms can help us as well. The other feature is mostly in performance improvement, but it actually allows us to run it across much larger graphs, which previously would have been prohibitively expensive because the query would simply have taken too long. And this is if I have a query where I know I can cut off certain branches. So for example, I'm only interested in following branches where a certain attribute is set. So for example, imagine again, we're in our k-shortest path example. We want to find routes from A to B, but now we actually want to avoid routes which go, for example, across any major highways. Course, we just committed a bank robbery and we just want to avoid highways, for example. So this is our prune feature here. The other feature, and as mentioned already, this hasn't quite made it into the 3.50 release as we were doing intensive testing and performance optimizations, is the hot backup feature. And this allows us to take snapshots of our cluster in a really fast way, because we don't actually dump all the data as we would do with Arango dump, going through all the collections and creating like a equivalent insert statement, but we actually just take a snapshot of the underlying file system on each DB server in a coordinated fashion. So first of all, this isn't impacting the search engine or the query capabilities of ArangoDB, because it's kind of done outside and it's not going through the search engine. The only impact it actually has there is a very short period in which we need to synchronize, because we want to take that snapshot consistently across all the different nodes. But that's a very short period of time, especially compared to using Arango dump. And so using that, it actually allows us to take snapshots also in a much higher rate compared to other backup options. The other feature, oh yeah, thanks Mike for that comment. I can switch over. I was actually just wanted to keep my view up and see what slides are coming up next. So it was just my convenience. Mike just commented that I'm not in presenter mode. Happy to switch over, but that was just for my own convenience here. So data masking. Especially here in Europe, we are already dealing a lot with GDPR, and in areas like California, there are actually similar laws being implemented right now. And this means it might make it quite hard, because we actually have to mask user data. And we still want to keep certain characteristics the same. But so, for example, our developers shouldn't be able to see privacy-related information. So for example, if we have here a document which contains multiple private information, so for example, name, credit card number, or birthday, which under GDPR all have to be masked away, we can use the data masking feature, and it will still kind of preserve that structure. So for example, we still have the same date structure for birthdays. It's just a random different birthday. We still have kind of the same format for credit card numbers, and also names are still following the same string format. And this actually makes it easy to test our applications on top, because we don't have to rewrite them, and we also don't have to expose them to this private information. Next, time to live index. So also under GDPR, it might be very useful to only have certain lifetimes in which we store information. So for example, if we only needed, imagine we have our shopping cart app, so people are shopping, but we have to ensure that we actually delete all that information after they are done with their shopping session. And so this is where a time to live index can be really useful, because it can basically say, I want those records only to live for the next 2 days, and after those 2 days, they should be deleted. And this is useful also in cases where, if, for example, I just want to build a cache across another data structure, and I don't want to keep stuff around forever, because otherwise my database will simply grow too large. All right, those were actually already the cool features. And having that said, I would actually switch over here. Cool. Here we have our demo environment, and I actually, let me double check why my deployment didn't come up. I think I either have hit a limit or it didn't come up quickly enough. But fortunately, I already created one up front. So here's my Google Cloud deployment. And here we can actually see all of the different details. So I have all my access details. So if I want to connect using Arango import or any of the other tools, this makes it really easy to connect. I can see what configuration is being used. So here we're using 3.5.0, how much memory do we have on the coordinators, and so on and so on. And especially important, I can see the state of my servers. So we can also look at details here. So we have a number, we have 3 agents, 3 DB servers, and 2 coordinators for our workload. And we can also have alerts, for example, like when disk usage is running full, which is a common issue if you don't monitor that yourself. So basically, it's kind of like a best effort deployment for ArangoDB, which we actually maintain for you. Okay, let's switch over to the database. And for that, I need to copy the password and move my line here. And here we have our 3.5.0 UI, which if you have worked with ArangoDB, probably looks familiar to you. There are not too many changes, so you should actually feel right at home here. In terms of nodes, again, we can see which coordinators we have. We can see, I again have to move the zoom stuff, which you probably can't see, but it's like annoying on my screen here. And we also have our DB service here. So if we actually want to connect or use any details to further investigation, we can do so as well. We can have a short look at our charts. So I already created some stuff up front. And so if we look at our collections, I basically just imported a number of data sets which might be useful for our queries later on. And I also already created 2 graphs. One's a train graph with different train connections, and one's probably, if you've worked with any demo in the ArangoDB ecosystem, the IMDb graph with all the movie information here. And this actually then brings us to our queries. And let me just again move this. And I already stored some queries up front. So for example, here, let us start with the shortest pass example, because that's a pretty easy query here. And so for that, we can figure out the shortest pass between, but that's actually my PRUNE query, I see. Huh, interesting. Give me 1 second. Okay, so this is not my shortest pass query, but this is my PRUNE query, also good. So let us start with that PRUNE query, actually. So with the PRUNE query, it's using our airports data set. So if we look at that, we have a number of airports, and they have certain features. So for example, especially important is like this VIP feature, because those are cool airports we might want to land at, because we just want to ignore all smaller airports. And then we can we want to figure out how to go from A to B. So basically, which airports can be reached from Denver, only using VIP airports. And if we run that, here, we kind of get our nice graphs, which airports we can all reach. But I think this is kind of not the so interesting part, because I mean, this we could have already done before. What we actually care about is what's happening here. And for that, let's actually look at the explain graph here. So let's explain our query. And so here we actually see that for those nodes where otherwise we would traverse down the entire path, we can actually prune it off before. So we don't have to go all the way down. So maybe let me just show that result again, because that makes it actually very easy to explain. Execute. And Google seems to be very slow today. I don't know why this is taking so long. So if we look at our graph, what otherwise would have had to happen is that we are actually going down all the different paths, and then later on we would filter out. We would basically filter out which VIP airports are true. So prior to that, we would actually have to build that entire graph, and then later on we throw away results which we don't need. What we can do right now is we can actually drop any non-VIP airport while traversing through this data graph. So we don't actually have to touch any path which is going through an airport which is not a VIP airport, which is really drastically reducing the intermediate result set, and also drastically reducing the query runtime for that. All right, this is our prune feature. So let us actually look at the other feature, which is our SmartJoin feature. And this is actually using our orders and products collection. And so for that, let's have a short look. So here it's pretty simple. Our collection, it simply consists of some product IDs, some items, and so that was our orders. And so here we have different products which can be ordered, and then as we just saw, our orders collection is basically just what was ordered here. Now, if we have queries like that, where we basically just want to have a join, prior to that, what would have happened is those shards could have been distributed across all different nodes. So for example, if we go back here and we look at the charts here for products, we can see they actually live on different database servers. Every shard is living on a different database server. And if we actually do the same for orders, we can also see that it's living on the same database servers. And so not using the SmartJoin feature, it actually probably would have had a lot of traffic between those different database servers, because a lot of those data would have had to been sent between the different nodes. But luckily, we used this command we saw here, so distributed charts like, which actually ensures that those charts are distributed exactly alike as those charts. So our join query here can simply run locally. And again, we can see that. Let's first of all just execute it. Yeah, we get what we expect, basically the join between those two collections. Not so cool. But the actual cool thing is, if we look at the query plan here, we can see we have used the SmartJoin optimization. And this actually means that in between here, in those nodes which run across all shards, can actually run on each database server and don't have to be run across different database servers. And then only the gathering of the final result is actually involving network traffic. All right. Let me just see whether I find that query I was looking for earlier in my history somewhere. Show query history. Nah. Otherwise, no, sorry, I don't have my shortest pass query right now, but it's pretty straightforward. We're just asking what is the shortest pass across here, our train graph. So if we look at our graphs, basically just how can we get from Brussels to Cologne or other cities in the fastest way. Okay, let us switch back, and let's also switch back then to presentation mode. And what would be the next steps? So if you actually want to test that out yourself, you can go to arangodb.com. As said, you can also register for the free trial for Oasis. And then you don't even have to set up the cluster, but otherwise you can also just download it from ArangoDB yourself, all the binaries for your favorite distribution or your favorite operating system. There is a quite extensive release blog post about the different capabilities. And there are actually multiple tutorial videos for most of the individual features on the site ArangoDB 3.5, the landing page for this release. If you're actually interested what's coming next after 3.5, there will be a webinar on October 10th about these 3.6 features. So feel free to register for that as well if you want to know, or actually also give feedback for what are the next steps. Otherwise, thank you so much for listening. And thereby, I would actually open it up for more questions or also feedback, whether that's something you need or which is helpful for you. You can additionally also ask questions in the community Slack. So if after this webinar you have any follow-up questions, feel free to just jump into the RangoDB community Slack and ask any questions there. If there are no further questions, thanks, Matt, for Mike is asking, does your company offer learning material? Yes, of course. So for example, here, if you go to the arangodb.com page, let us, for example, just go to our landing page here for the 3.5 release. So if you want to learn more about the 3.5 release, we got videos on all the key features. We got tutorials on the different features. So for example, if you want to look up that shortest pass query. Actually, let's just take it from here and go back, because I actually just stole it from here. Very good. Safe. So for example, here, if you're looking for learning material on the queries you didn't save in the editor before, you can easily go to our webpage and find them there. And here now we actually have our example for shortest pass queries. So how can we go from places Lucas to Cologne in our train graph, and we actually want to get the entire pass back here. So this is the shortest pass feature here, and those is basically our learning material. You can dive into further for more information on those features. There's a lot of here under learning, a lot of introduction material to learn about graphs, document search, operations, development, and other operations. If you actually have further questions, you can go into the community Slack and actually ask us questions there. I use SQL, so how easy is it to use AQL instead? AQL is actually pretty similar to SQL. So the feedback we've gotten so far is that actually it is very easy to pick over if you already are familiar with SQL. And as mentioned earlier, the other feedback we also often get that it's very easy because I don't have to learn a new language for like each of my different data models. Whereas if I'm otherwise dealing with graphs, documents, I actually have to learn a new data model for each of them. Cool. Thank you so much for your questions. Wait, here's another tab with 2 more questions. So how different is the enterprise support versus the community support? Some of these features are actually enterprise features. But our approach is to actually enable the features you need to really run your database, that those actually remain in the community, and features which basically help you in enterprise settings, that those are open source. But you as a developer on your test project, you should always be able to run the community version. So the other question here is, do you have a .NET Core support in the near future plans? We actually, this is the second time this question is coming up, so we have a backlog item for that, and I'll definitely take that and add it as another demand. Feel free to also just ping me on the community Slack, Jörg.ArangoDB, if you have any further specification what exactly you would need. But I suppose this question is actually mostly about that you care about having driver support for .NET. Cool. If there are no further questions, thank you so much for listening, and hopefully see some of you at the next webinar around 3.6. And feel free to just try out ArangoDB. Thanks for listening.